Hey, welcome everybody. My name is Sebastian Maniak, and today we're going to dive in how to deploy and just show you and share with you some Terraform code, how to deploy a Fortigate firewall in Azure using Terraform in an active passive state. So, why use Terraform? Well, Terraform is a powerful infrastructure as code IAC tool that allows us to define, deploy, manage cloud resources efficiently, right, and effectively instead of manually creating resources in Azure or any other cloud. We'll use Terraform to automate the deployments of the Fortigate and ensure like consistency and scalability. So today what we'll cover is the architecture, how to set up Terraform with Azure, how to write some of the code and show you some examples and give you access to the repo, and then validate and test our configurations. From a prerequisite to begin, we'll need an Azure subscription. You'll need Terraform installed. And what we'll be doing is we'll be doing the pay-as-you-go license inside of Fortigate itself. So the first thing we need to do with Terraform is build out our network. So let me share my screen here. Right, we need a resource group being built inside of our region. So in here, we're just going to use Canada Central. Inside of this resource group, we're going to deploy our VNets. So this will give us all the access we need. So our virtual network, our subnets, that's going to house our public or our untrust subnets, our private or our trusted subnets, our HA sync subnet, our management subnet itself. Then within these subnets and these resource group, we're going to deploy a Fortigate device with 4 interfaces, one for each subnet, public, private, HA sync, and management. We're going to deploy security groups and routing rules inside of our configuration, and we're going to ensure that our load balancers are configured in for the public and the private, so we could load balance traffic across these 2 Fortigate devices. And we're going to split these up into 2 different availability zones for high availability itself. So let's get started and take a look at the Terraform code. All right, perfect. So here we have our Terraform code in here, and you can visit this GitHub. I'll post it inside the YouTube notes where you can get access to this deployment, and it's pretty straightforward. Well, in essence, we're going to be building out the infrastructure itself. So the first thing we need to do inside of our network, let me make this bigger, is build out our Azure resources and build out our provider. So we're going to be using the Azure RM provider in here. We're going to specify the versions that we're going to be using for this RM provider. We're going to configure our main resource. So in our main.tf, we're going to create a resource group just called my Terraform group. You can change this however you want. You can change the name. We're going to have our tags associated to us, and we're going to set up marketplace agreements because we have to accept this marketplace. So to get this started, why don't we run the code first, initiate it, and then we can kind of talk about what is going to happen. So I'm going to open up my repo here, and the first thing I'm going to do, let me just go to the folder. I'm going to initiate Terraform init. So this is going to initiate Terraform, download all the specific providers that I've requested, and then start creating And then it allows us to really start building out the configuration. After Terraform init, we're going to do Terraform plan to validate that everything is working, everything is correct, and validate our configuration. And as we see when we did Terraform plan, we see all the outputs of what we're going to be deploying. So if we scroll up quickly, we see the virtual networks that are going to be created, the interfaces, um, more interface examples here, IP addresses, the routes, the tags associated to here, the public subnets. We got no errors, so that means everything looks very good. So why don't we go ahead and deploy this? And from the output, what we're going to get is a management subnet, a passive public IP address, a password, resource group, and a username to log in. So let's do Terraform apply. Terraform apply is going to run through that plan again to validate that, and well, it lets you know what changes we're going to do. So you can go ahead and take a look at what things are going to happen. We have this plus sign, just indicates that we're going to add this type of object inside of our Azure environment. So we're going to click on yes. And now Terraform is going to start executing and is going to start building out those objects we've identified in here. So it's going to start by building out our resources group, our management subnets, etc. So let's switch into our Azure portal just so we can see what's happening in here. So we can see that we have that Terraform resource group was created. It quickly built out or reserved public IP address for the active management Fortigate. Created two interfaces right now. We created a client machine just for testing purposes. Created our external load balancer, our internal load balancer, created our routing table, created our passive management IP address, two interfaces, created two network security groups, one for private and public. And as we refresh, we see more objects being created through Terraform. This takes about 5 to 6 minutes to build out the entire Fortigate device, but it allows us to build out as many as we want by literally just changing the parameters inside of the Terraform code. So let's take a look at some of those parameters. All right, let's take a look at this network itself. You can take a look at the code yourself in your time. I'm not going to kind of dive into it, but you'll see on the bottom right hand side what's happening. It's trying to build out the VMs right now, and that takes the most amount of time as we're building out a beefier box, and it takes about 5 to 6 minutes to get a virtual instance online in here. So the most important part in this configuration is the variables section. And inside of the variables section, we have to configure a bunch of settings. One, to get access to our Azure subscription, we have to be able to fill out our subscription ID, our client secret, and tenant ID itself. If you take a look at the example var, you'll see that this is where I've populated my my IDs and my secret in here. I just deleted it because I didn't want to publicly show that. But you'll have a Terraform.tfrs that looks exactly the same with your data and your information, or you can export that into your environment variables. So if we take a look at the code, the first thing we do is what kind of size? What are the size of the FortiGates we want? Visit the Fortigate website and visit the Azure website to identify what suits best for the type of throughput and the type of services that you're going to be running. We give the firewall a name, so firewall 1 and 2. You can change the name in here. select what zones is available. So of course, take a look at the availability zones in the region that you're going to be deployed in, and you can classify which zone to put what firewall. Specify the location. So I'm deploying this in Canada Central. There is an option in here to be able to build a custom image that you can host inside your own Azure blob with the custom image that you want. Maybe you already built a custom image with specific configs. You can bootstrap it itself. Then you have the option of setting what type of licenses, be it pay as you go or bring your own license. So you've purchased a license from Fortigate. You can import the license.txt file inside of this repository and it'll be able to pick it up. We can pick the type of instance architecture, ARM x86. I've already accepted the marketplace agreement. So you can set that to either true or false. If you haven't, you set it to true, and we'll accept the marketplace agreements below. If you have those license files, we're just looking at the file directory in here that focus on this. And if you've set your accept marketplace agreement license, here's the information that you have to accept, or here's the actual SKUs for the pay-as-you-go licenses for ARM and x86. That gets automatically accepted. Then we specify the version, so 761. I believe that's the latest version right now. Then we have our username and password in here. We are also making some configuration changes. So we're making sure that the management port only runs on 8443. And then based on the VNet CIDR block we've allocated in here, we're specifying what's the IP range for the cyber block, what's the IP range for that public private subnet, what's the HA subnet, what's the management subnet. And then we are setting static IP addresses for all the interfaces. We could set this to DHCP, but from a networking or firewall perspective, I like to use the first 10, 12, 15 IP address dedicated to infrastructure alone. And then we go through setting up all the interfaces for ports 1 through 4 on both active and passive deployments. Specify the gateways, because we really need the gateways to be able to route out and route into the network, and also for the internal and external load balancers to be able to connect to the device. Now it looks like our active unit is online, and now we have our passive unit being built, which is great. We have our internal load balancer IP address. And then the next important part is bootstrapping the actual Fortigate device. So we have the Fortigate active configuration and the passive configuration in here. And all this is just the conf file. Literally, it is the CLI commands on what's going to get executed once that Fortigate device comes online. Then we have our license information in here. If we do bring your own license, you can just change the file or put it to a different location or however you want. And then we have common tags in here that we want to tag all the specific resources in here. So let's take a look at, once this is built, how are things being bootstrapped. So if we take a look at our folder in here, we have our two files, our passive and active configuration in here. We can get more creative, and I'm going to get more creative in the active deployment, where we're just using a more advanced Jinja 2 template. But in here, we have our global configurations. We have our names that's going to be set from our variables. All the information gets ported over here. Literally, as the Fortigate boots up, these configs just get automatically executed. As we're going to set the host name, select that port, which was 8443, select time zones. Then we want to select or configure our probe response. So when we're load balancing the Fortigate device across availability zones, by default, port 8008 is being used with an HTTP value OK. And we have to assign these probes to the interfaces that the load balancer from Azure is going to actually validate. So when we configure our interfaces, we get to pick which one are we going to use for public or private itself, or untrust and trust. And we have to ensure that we allow access to the probe response. Once we, and you can't see this in the GUI, so this is a CLI command only that you have to enable first to be able to see this feature inside of the Fortigate devices. So we have one for our untrusted environment and our trusted environment itself. The next thing that we're doing in this configuration is also setting up HA sync. So we're syncing the two devices. So, sessions are synced, configurations are synced. Everything works as one. We only have to log into one to be able to manage the device. Or if we have a FortiManager, we use that device to manage it itself. We configure the peering by using the peering IP addresses configured, or the HA addresses. Then we have to configure the static routes. So we have a default static route to go out to the internet. And then we have two specific static routes pointing to or destined to this IP address, 168.63.129.60. This is the Microsoft Azure load balancer probe IP. So we have to ensure that both the untrusted or trusted or public subnet interfaces and the untrusted have a route out to it through their designated interfaces, because we need this to go online so the health monitor can go online. So then we can validate which Fortigate is online. And then the last thing we're doing in here is we're adding the Azure SDN connectors, where we're specifying that tenant, subscription, and client ID. This will help us to manage the address groups and manage objects within the environment more effectively itself. And then we have our default routing table, and that is pretty much the end of the active config. And the same concept is with the passive configuration. It's literally the same configuration file that we're specifying it, other than we're pushing different type of variables to it as active peer ID itself. So now that the Fortigate devices are online, Terraform outputs the configuration for us. And we can access these devices to validate our configuration. We have our username that we're going to use and the password that we've created. So let's open up these devices. First, let's just validate all the resources that were built inside this resource group. So if we just refresh this page, we'll see we have our active Fortigate device. We have our passive Fortigate device virtual machine deployed. We have our IP addresses, disks, interfaces, subnets. Look at, for example, our external load balancer and go to the load balancing rules, and we'll just select this default rule. We could see that this is the active Fortigate device that's up, and we have the other one down because the probe response is down for it, because we have an active passive configuration itself. We've noticed our external load balancers are connected. We could take a look at the Fortigate devices. So we'll log into our Fortigate device. Zoom in. And we see that this device is configured in HA. It's synchronized. We have all our interfaces configured, and we have the two probes deployed for internal, external, or untrusted. We go to our HA settings. We have our configuration synced. We have all our settings configured that we deployed. So, and if we log into the other device, we could see the same. Perfect. We have this, our secondary is successfully configured itself. And for example, if we create a new policy, just as an example, apply all to untrust to trust. Let's say source all, destination all. Just as an example, sure service FTP. So now that we've applied this configuration, this is going to get synced to the the passive device. And we can validate that by logging into it, go into policies, firewall, and now we see that same policy in here. And we can definitely delete it here. And then that gets synced to our other device and it's gone. So with this configuration, we've deployed this active passive Fortigate environment inside of Azure. Probably takes like 10-15 minutes to get everything deployed. And especially since we use Terraform, so infrastructure as code, we could then delete itself. So once we're done with the environment, all we need to do is do Terraform destroy. Terraform will automatically validate what we're going to destroy in this environment. So it's refreshing its state, and then it's going to output all the information. So because you see minus, it's going to remove every single deployment. And then if we're okay with that, we're going to press yes. And then Terraform starts removing all the objects, all the virtual servers in the specific order, starts destroying it, and deleting all the resource groups. So this really allows us to kind of have infrastructure as code using Terraform to deploy an active passive Azure deployment. And if we jump in here, refresh, we'll start seeing our infrastructure slowly get removed as this configuration changes. So here's the repo that I've posted. There's an Azure active passive deployment across availability zones. All the information on how to use it is located right here. Feel free to try it out. I'll be doing more of these Fortigate Terraform deployments throughout the month of February. If you like this video, please like and subscribe.